Hello students, I welcome you to this module once again. The name of the module is Foundation Phase Mathematics Teaching. The module code is FMT3701. This presentation follows on from presentation 1 and therefore this is now presentation 2. This is an overview of presentation 2. In this presentation, I will cover 5 topics, namely fractions, patterns, measurement, shape and space handling. Now, the first topic that we will cover is fractions. As you can see, here there is a very creative bird and you can see different fractions. What this picture means is that fractions can be taught in a fun way. So when you are teaching fractions in the foundation phase, please make sure that you engage your learners in as many practical activities as possible. Involve them in practical demonstrations. Link your activities to real-world experiences. Let your children see the relevance of fractions in their daily life and so forth. Fractions can be integrated even in during your art lessons, during your physical education lessons, even in your language lessons, in your storytelling and so forth. Now, let us see what is fractions. What is a fraction? A fraction is a part of a whole. For example, slice a pizza and you will have fractions. In the first pizza, you will see that it is cut into 2 parts. Each part is called 1/2. In the second pizza, you will see 1/4. In the third pizza, you will see 3/8. This means that that pizza is cut into 8 equal pieces. Now, let's look below. This is a fraction of 3/4. In this pizza, you would see that there are 4 equal parts, but what you see there is actually 3/4. And that is how we write 3/4, 3/4. The top number is called the numerator. The bottom number is called the denominator. The denominator says how many equal parts in the whole object. The denominator says exactly how many equal parts in the whole object. Now let's look at this diagram here. Here you can see that there's a circle and the circle is divided into 2 equal parts. So each part is called 1/2. The 1 on the top is the numerator and the 2 at the bottom is the denominator. The 1 means that there's 1 out of 2 parts. Let's look at these examples. How many equal parts are there in this shape? You can see that there are 4 equal parts. Then, what is the denominator of this fraction? It would be 1/4. The 4 means that there are 4 equal parts. Now let's find the denominators of these shapes here. The circle will be 1/4. Yes, 1/4. The triangle, 1/, yes, you guessed right, 1/3. The square, it's 1/2. Or you could say the diamond. And the rectangle, as you can see, there are 2, 4, 6, 8 parts. So it's 1/8. Now, let's move on to the numerator. The numerator says how many parts in the fraction. 1 part is colored in. Therefore, it is 1 out of the 2 parts. How many equal parts are colored in this shape? You can see that there are 3 parts that are colored. Therefore, the numerator will be 3 out of 4. Find the numerator for these fractions. In the first what do you think it will be? Yes, 3/4. In the second diagram, yes, you can see it's 2 colored. It will be 2/3. In the third diagram, there's 8 equal parts, but 1 is colored, so it's 1/8. In the fourth diagram, there are 8 equal parts, and how many are colored? Yes, it is 5/8. Find the fraction of these shapes. Now that you've learned what is a numerator and what is a denominator, test yourself. Find the fraction of these shapes. Let me give you one example, and then you can continue with the others. How many equal parts are there? 2, 4, 6. 6 equal parts, hence the 6 will become your denominator. Now, how many parts are colored? It's 2, 4. So the 4 becomes your numerator. Hence, in that shape, the fraction is 4/6. Let's do another example, the one on your right. The square. How many equal parts are there? There are 4 equal parts, and that becomes your denominator. How many of the 4 equal parts are colored? Yes, it's only 1, and that therefore becomes your numerator. Right, now let us move on to unitary and non-unitary fractions. Have you heard of the word unitary? What does a unit mean? Unit means 1. Here are some examples of unit fractions. A unit fraction has 1 as the top number, which is the numerator. In the first diagram, it's 1/3, 1/10, a fifth, a half, and 1/4. With unit fractions, when the bottom number, which is called the denominator, is bigger, the value of the unit fraction is smaller. Now, let us look at what is a non-unit fraction. Unit means 1, so non-unit is any number apart from 1. Here are some examples of non-unit fractions. A non-unit fraction is many parts of a whole that is divided into equal parts. Look at the first circle. There are 3 equal parts, so 2 of the 3 equal parts are colored, hence it is 2/3. So because it's not a 1, the numerator is a 2, hence it's a non-unitary fraction. And the next, it's 3/5 and 2/4, 5/8, 5/6. Students, you need to know what is a unitary and what is a non-unitary fractions. Because when you teach grade 3, these are some of the concepts that you need to cover. Now, let's look at what are equivalent fractions. Equivalent fractions have the same value, even though they may look different. These fractions are really the same. 1/2 is equal to 2/4, is equal to 4/8. Why are they the same? Because when you multiply or divide both the top and the bottom, the same number, the fraction keeps its value. For example, 1/2. If you multiply the numerator by 2 and the denominator by 2, you get 2/4. If you multiply the 2 of 2/4 by 2 and the 4 of 2/4 by 2, you get 4/8. Hence, these are fractions. Let's look at the diagram alongside the fraction. There you see 1/2 of the pizza, and then you see 2/4 of the pizza, and then you see 4/8 of the pizza. Can you see that all of them are equal size, but written differently? The rule to remember is change the bottom using multiply or divide. And the same to the top must be applied. Here is why those fractions are really the same. Look at the fraction wall and you will see why 1/2 is equal to 2/4, which is equal to 4/8. Okay. Now, let's move on to word problems related to fraction. We cannot add two fractions if the denominators are different. And that is what we call unequal denominator. Hence, we cannot say that 1/2 plus 2/4 is equal to 3/6. The common misconception or error many students make in calculating fractions is that they add the numerators and then they add the denominator and they come up with an answer. Add a fraction with unlike or unequal denominator. Now let us look at this example here. A restaurant served a total of half a loaf of bread and 6/8 of a loaf of white bread. How many loaves were served in all? Now, firstly, you need to draw for this word problem. How would you visualize 1/2 of a loaf of bread? How will you draw 6/8 of a loaf of bread? Well, 6/8, you draw a loaf of bread and you will divide it into 6 equal parts. And then you will color 6 out of the 8 parts to show that that was what was used. Now, so 1/2 plus 6/8, that is what you need to add. In step 1, you'll notice that the denominators, the bottom numbers are different. Since the denominators are different, we must rewrite the fractions so that they both have the same denominator. Therefore, we must find the least common denominator for 1/2 and 6/8. To find the least common denominator, we must find the least common multiple of 2 and 8, which are the denominator. Now, this is what you will do. You will write down all the multiples. For example, 2, 4, 6, 8, and all the multiples of 8, 8, 16, and 24. From the two sets of numbers, which number is the common number? In which number is repeated as a multiple of 2 and the same number as a multiple of 8? Yes, we see that the number 8 is the common multiple. Therefore, we call it the least common denominator for 1/2 and 6/8, which is number 8. Then step 2, write the equivalent fraction for 1/2 with 8 as a denominator. We don't need to write an equivalent fraction for 7/8 because 8 is already the denominator for this fraction. So what we do is we will multiply 1 by 4, in the symbol 1/2, we multiply 1 by 4, and the bottom 2, we multiply 2 by 8, and we get 4/8, which is now, as you can see, the denominator is the same as 6/8. And then it becomes easier to add, so you will add as 4 plus 6, which is 10, and 8 plus 8, which is 16. And then you will simplify that fraction. Now, this is the steps for adding fractions with unlike fractions. Firstly, you need to identify the least common denominator for finding the least common multiples for the denominators. Then you need to write equivalent fractions to make sure that each fraction contains the least common denominator. Add the equivalent fraction that you wrote in step 2. The denominator is the same, and then you need to simplify if necessary. Colleagues, I do not want to go in detail with adding and calculating like and unlike fractions. I've attached a number of very, very useful YouTube links here. And these links will cover important concepts related to fractions and, the length models, the set models, the area models, it will help you to deepen your understanding about numerators. Please, I urge you all to click onto these videos and to watch these videos. I promise you, these are short videos and you're going to really gain a lot by watching these videos. Okay, let us now move on to the next section. The next topic is patterns. Okay, as you can see, patterns are everywhere. It's in numbers, it's in alphabets, it's in shapes, it's in nature. So we will talk and we will investigate and explore different types of patterns. Look at this arrangement of flowers. Do you think it follows a certain order? One yellow flower, two reds, one yellow, two reds, one yellow, two reds. An arrangement that follows a certain order is called a pattern. Patterns are all around us. Now, let us look at the different parts of a pattern. And this is important, students, because you need to know what are concepts such as core, the element, structure, and so forth. Repeating patterns have two main parts, the terms and the core. The word term and the word core, it's important for you to know. Now, what are terms? Terms refer to the object or the elements that forms a pattern. So in the example that I've given you here, you see that there are 2 stars, 3 circles. So your terms are your 2 stars and your 3 circles. In the pattern above, the terms are orange stars and green circles. That's your terms, orange stars and green circles. Now the core is the part of the repeating pattern. And what is repeating itself there in that pattern? Yes, it stays the same and repeats itself. And that is why it's called the core, is what makes the pattern. Here the core is made up of 2 orange stars and 3 green circles. 2 orange stars, 3 green circles. 2 orange stars, 3 green circles. That is the core. Okay. Now look at this activity here. I want you to try to identify the core. Find the core of this pattern. Look at the smallest set of the term that represents itself. Okay. It is the hashtag with a $sign, $2. So what is the term? The term is going to be the hashtag and the $sign. But the core is going to be hashtag $2. Then it's 2 hashtag $2. 2 hashtag $2. Okay. Is this part the core? Okay. The hashtag and the $sign. Is that the core? No. Why not? It's because the core is the hashtag $2 and the hashtag. Is this part the core? Hashtag and $2. Is this part the core? Hashtag $2 and hashtag. Yes, these are the terms that repeat over and over in the same order. Can you see, colleagues? This is a bit of a complicated example. Okay. Patterns. Read the following word problem. Identify the input value and output value. Illustrate the word problem pictorially. Represent the word problem in a table format and ask 5 questions to stimulate algebraic thinking. This is an activity which I would like you to do after you've studied the concept of patterns. Now, identify the input value and the output value for each example. Here, I've given you some examples, okay? Each table in the restaurant can seat 7 people. If the restaurant seats, 8 tables, how many people can sit at the table? So your input is, and your output is 7 people. Okay, for each table, there will be 7 people. There are 6 face masks in each box. If Ashley bought 4 boxes, how many face masks will he have altogether? So 1 box is your input and 6 masks is your output. Benson reads 4 books in a week. How many books would he have read in 5 weeks? So in 1 week is your input and output is your 4 books. Mandy used 5 oranges to make a glass of orange juice. How many oranges would she need to make 5 glasses of orange juice? The 1 glass of orange juice is your input and 5 glasses is your output. Okay. So if you look at this, your input and your output, if you have a good understanding of your input and your output, then it would lead to algebraic thinking. If you know 1 table will seat 7 people, 2 tables will seat 14 people, 3 tables will seat 21 people, and you go on in that way to get a pattern, and that promotes algebraic thinking. Okay, what is a function? A function relates an output to an, a function relates an input to an output. It is like a machine that has an input and an output, and the output relates somehow to the input. 3 main parts to a function is the input, the relationship, and the output, as you can see in this diagram here. Now, let's look at patterns again. Patterns are all around us. Pattern is something that is arranged following a rule. The pattern part of the pattern is called the core. Each piece of the pattern is called the term. The element refers to the objects used in the pattern, and the attribute describes what an object looks like. Okay, so these are concepts related to patterns. Now, let us look at what number patterns are. Provide your own interesting example related to real-life situation to show the relationship between 2 sets of numbers. Explain the input value and the output value. And I want you to illustrate this with pictures. Represent this relationship in a table format as shown in your prescribed book. Write down 5 appropriate questions you would ask learners to develop algebraic thinking for a discussion. Students, I would love you to actually practice this year now that you know what are number patterns. Okay, so this is a very good activity that's going to help you to consolidate the concepts that you've acquired in related to patterns. What are cores, what are elements, terms, the function, and so forth. And remember that the reason why we teach patterns in the foundation phase is to develop the algebraic thinking for children. Okay. The next topic that we will talk about or explore is measurement. As you can see in this slide here, for a deeper understanding of measurement, please refer to the prescribed book, chapter 3. Right, and measurement is about time, it's about height, it's about temperature, it's about weight, it's about length. So let's go. Here, when you are teaching measurement in the foundation phase, there are important steps that you need to follow. These steps will guide your strategy. The important thing when teaching measurement is you need to introduce the concept of measurement in practical ways. Let the children explore. Let the children experiment. Let the children experience measurement themselves. Let them do. Let them measure themselves. That is how they're going to learn and discover. And introduce them to measurement through problem-solving activities. And you must have plenty of concrete objects available for your students. Now, these are the 4 steps that are critical when teaching the concept of length, for example. Quite often, there's a misunderstanding with what is length and what is distance. What is length? Length is how long objects are. What is distance? Distance refers to the space between 2 objects or the point between 2 places. Now, step 1 when you are teaching measurement is learners must understand the specific features that must be measured. Now, if you look at the concept of length, what are you measuring in length? You are measuring how long the objects are. Then if you are measuring distance, what are you measuring? That is a feature. You're measuring the space between 2 objects or the space between 2 places. The units of measurement for length is non-standard units, which include feet, steps, rope, paper, and so forth. And then you have standard units of measurement, which include rulers, measuring, and tape. And step 3 is learners must know the measurement strategy. What measurement strategy are you going to use here? You're going to measure, you're going to start at one end of the object and measure up to the other end. When you're measuring distance, you're going to start at one end of an object and move close to the other end of the object. Step 4 is learners go on to use number measurement to develop and solve real-world problems. Measuring length, how long is my pencil? Measuring distance, how far is my desk from the door? And this is a real-life world problem, okay? Let us look at what activities to measure mass. What is mass? Mass refers to how heavy or how light something is. Step 1, your learners must understand the specific features that must be measured. And when you measure mass, you are measuring the mass or the weight of the object. Step 2, learners must understand the units of measurement. Then, what is the units of measurement of mass? In grade 1, you would use non-standard units, such as hands, balance scale, etc. And then in grade 2 and grade 3, you'll use standard units, kitchen scale, bathroom scale, spring scale, and so on. Step 3, learners must know the measurement strategy. You use informal measurements and formal measurements. Compare the mass of objects by putting them on a balance scale. That is your informal measurement. And think of how the vendors sell goodies on the street. They don't have scales, but they would estimate, they would put them in bundles, or they would think of how they would sell nuts, for example, in little cans. They would fill up the can, and that is how they measure. Then you have formal measurement, where you find out what is lighter, the heavier mass, and so forth. Then step 4, learners go on to use number measurement to develop and solve real-world problems. Measuring mass, for example, which object is heaviest or lightest? Now, let us look at planning activities for perimeter and area. Perimeter refers to the length around an object, and area refers to the how many shapes will cover a flat surface of an object. So when you are measuring in step 2, units of measure for perimeter is hand, feet, strings, ropes. And the standard units is ruler and measuring tape. The area, the standard, non-standard units for area is hands, shapes, tiles, etc. The standard units would refer to the ruler, the measuring tape, etc. Step 3, learners must know the measurement strategy. Measuring perimeter, starting at a specific place on the edge of an object and measuring around the object, stopping where measuring started. And measuring area, start by using the flat objects to cover a flat surface and count how many objects will cover the surface. Now, the problems, the word problems related to perimeter. How many hands would it take to go around my desk? Area, how many square blocks will cover my table? Now, let's look at time. The concept of time will be covered in the same way. And students, I want you to read this for yourself. Let us now move on to space and shape as the next topic. Okay. In this topic, you need to understand what is a two-dimensional shape and what is three-dimensional objects. Now, two-dimensional shapes has a width and height. They are flat and they have no thickness, as you can see here. For example, triangle, square, pentagon, hexagon, octagon, circle, rectangle, oval are all two-dimensional shapes. They're flat, they've got no thickness. All that they have is a width and height. In contrast, three-dimensional objects is a solid object with 3 dimensions, length, width, and height. And there are examples like sphere, cylinder, cuboid, cone, hexagonal, square base pyramid, triangular base pyramid, cube, triangular prism. Now, let us look at the difference between 2D shapes and 3D objects. You will realize that you find 2D shapes in 3D objects. For example, a cylinder will have 2 circles on either side. A sphere has a circle. A triangular prism will have 2 triangles and rectangles. Okay. Right, now let us look at what is Van Heeler model. The Van Heeler level describes how young children learn geometry. It includes 5 levels of geometric thinking, visualization, analysis, abstraction, formal deduction, and rigor. Learners pass through the steps in order. In the early grades, you will use the first 2 levels of geometric thinking. This is the Van Heeler theory of geometric thought, which describes the different levels of understanding through which students progress when learning geometry. As you can see here, in the first level is visual. The learner is able to describe shapes on the basis of their appearance. Then in the second level, which is analysis, the learner is able to describe shapes on the basis of their properties. Then the third is abstraction. The learner recognizes the importance of properties and the relationship among them, which assists students in logically altering the properties of the shape. Fourth is deduction. The learner attains logical reasoning ability and proves theorems deductively. And the fifth is rigor. The learner establishes and analyzes theorems in different postulation systems. So in the foundation phase, the learner will progress up to level 3. Level 1, level 2, and level 3, which is visual, analysis, and abstraction. Okay. Now, this is an example of the visualization, the analysis, and the abstraction stage of the square, the rectangle, and the cube. For example, in the visualization level, the learner will describe the shape by appearance. The learner will say, this is a square. This is like a piece of cheese or a floor tile. And then for a rectangle, the learner would say, this is a rectangle. This is the shape of a box or a door or a book. For a cube, the learner would say, this is a cube. This is the shape of a block and a dice. In the analysis level, the learner would say, a square has 4 equal sides and 4 right angles. And in the analysis stage, the rectangle, the learner would say, a rectangle has 4 square corners, opposite sides are equal. So the learner would give you the properties. In the abstraction level, the learner describes the relationship between the properties of shape. A square is a special kind of shape. It is a parallelogram. Opposite sides are equal. It has 4 corners, opposite sides are parallel, and so forth. Okay. Now, the last topic is data handling. As you can see, data handling is all about graphs. Data handling deals with collecting, organizing, and representing information in a systematic way in order to analyze and interpret findings that are meaningful to others. you need to know the data handling cycle. In step 1, the learner, there is a problem. Data handling always starts off with a problem. For example, what is the most popular color toothbrush amongst the learners in our class? What is the most popular form of transport which learners use to come to school? So it always starts with a problem. So we call it question generation. Step 2, they collect data, which means that the teacher has to collect data based on the problem. Step 3 is organizing the data through sorting, classifying, and so forth. Step 4 is representing the data through graphs, picture graphs, bar graphs, and so forth. And then step 5 is analyzing and interpreting the data through questions. Who has the most, who has the least, who has 3 more, who has 2 less, how many more, how many less than, and so forth. Step 6 is reporting findings, and you go back and you answer the question that you want to solve. Colleagues, we have reached the end of our studies for FMT 3701, the end of the content, I should say. Okay, and in conclusion, I want to say to you, I wish you best wishes in your studies, and I wish you every success for your examination. Okay, thank you and all the best.